All right, let's do just a few examples using linear functions and writing linear equations. So here we've got a function, and they want us to write an equation. Okay, so we know it's going to be of the form y equals mx plus b. And just kind of by inspection here, we can see what b is, right? B is the y-intercept. So in this case, it's going to be 2. Now I have to figure out what m is going to be. Well, we can say, well, the change in y is going to be 2, 4, 6, and the change in x is 2. So 6 over 2 is going to be 3, right? And what if we didn't just count on the graph, but we wanted to calculate it with points? Well, we could say that's going to be 8 minus 2 over 2 minus 0, which is going to give us 6 over 2. Same thing, right? So we found our slope. It's going to be 3x plus 2. Ta-da! Hopefully that feels like something you know how to do. All right, now let's do a word problem. Let's do example 8. We've got Ben, and he's starting a company, and he has fixed costs of $12.50 a month, which includes his rent, and his production costs are $37.50 per item. So write a linear function where c of x is the cost of item for x items produced in a given month. Well, it's going to have the form mx plus b. And let's just think it's going to look something like that, where this intercept here is going to be his fixed costs, right? If he sells 0 items, he still has to pay $12.50. So that's going to be our b value. And what's our x value, or m value, right? Our m is how much it increases per item. So they tell us that's $37.50 times the number of items he produces plus his fixed costs. That would be an equation for Ben's costs per month. What if they just give us 2 points and they say f of 3 is -2 and f of 8 is 1, and tell us to find the equation for this function? Well, okay, we know it's going to be of the form y equals mx plus b. And from the information they give us, we don't straight off know either of these values, right? Whether m or b is what the values are. So let's find the slope first. So m is going to be the change in output values over the change in input values. So that's going to be 1 minus -2 over 8 minus 3. So that's going to be 3 over 5. Okay, so we know that our equation is going to look like y equals 3/5 x plus b. Don't know what b is. How do we find that? Well, we choose either of these numbers, either of these points, and plug them in for x and y. This is a case where knowing and using the point-slope form of an equation would probably be more convenient, but here we are. So if you want to do it that way, fantastic. I'm just going to plug these points in. -2 equals 3/5 times 3 plus b. Let's see, we get -2 equals 9/5 plus b. Subtract 9/5 from both sides. And let's see, that's going to be -10 minus 9, so -19/5 equals b. Okay, so we can plug everything in now. We know our slope, and we know our b value, and we're done, right? So first, find the slope, then plug points in or use the point-slope form, and find your equation in slope-intercept form. There were a few more problems I wanted to do. Marcus, he currently has 200 songs in his music collection, and every month he adds 15 new songs. Write a formula for the number of songs in his collection as a function of time. How many songs will he own in a year? Okay. All right, well, n of t is linear, right? It's increasing at a constant rate, and that rate is 15 new songs. So 15 times t plus, what's our initial condition? 200. Our y-intercept is 200. So there's our function, and they asked us how many songs will he own in a year? Well, n, that's per month, right? T is in months. So they're asking us, what's n of 12? Well, 15 times 12 plus 200. Let's see, what's that? 150 plus 30. So it's going to be 180 songs that he acquires over the year, plus 200 that he started with. He's going to have 380 songs in a year. All right, and let's do one last problem. Oh, wait, I think we have two more. We've got an insurance sales guy, Ilya, and he earns a base salary plus a commission on each new policy. So his weekly income depends on the number of new policies, N, that he sells during the week. Last week, he sold 3 new policies and earned $760 for the week. And the week before, he sold 5 new policies and earned $920. Find an equation for I of N and interpret the meaning of the components of the equation. Okay, so it's in this section, so it's probably going to be a linear equation. It's going to be of the form mx plus b, but m times n plus b, let's say, because instead of x, we have n, right? So you've got a base salary plus a commission. Okay, so if he sells 0 new policies in a week, he still gets his commission. Well, that sounds like the y-intercept, right? That's our b value there. So it's going to have the form m times n plus, well, we don't know what it is. So I just rewrote the equation. How can we figure out what it is? Well, we've got 2 points, right? They didn't tell us what the base salary is or his commission. They just tell us that if he sells 3 policies, he earns $760. And if he sells 5 policies, he earns $920. So let's find the slope, right? Slope is going to be, our m is going to be 920 minus 760 over 5 minus 3. So let's see, that's going to be 160 divided by 2, or 80. Does that make sense? He earns $80 for every policy. Yeah, that seems good. It's a good positive number. It'd be weird if it was negative or something. That would be a good clue that we'd done something wrong. But that makes sense. So let's rewrite this with an actual number in it. So it's going to be 80 times the number of policies he sells plus that y-intercept. How can we find that? Well, just like we did before, we could plug in one of these points. I'll choose this one because the numbers are smaller. We could say 760 equals 80 times 3 plus b. So it's 240. We can subtract that. We get 520 equals b. Again, that seems reasonable. All right, so we now have all the information we need. I is a function of n. His income as a function of number of policies he sells is going to be 80 times n plus 520. All right, so that's his base salary, and that's the commission that he gets for each policy. Okay, and let's do one last example using a table. Okay, so table 1 relates the number of rats in a population to time in weeks. Use the table to write a linear equation. So I'd say the first thing we should probably do is move out of this area where there's lots of rats that are growing in population, but if we can't do that, let's write an equation. So it's going to be linear, so P as a function of W. Let's check, is it linear? Well, the units on top are equally spaced, they're increasing by 2, and the increase in the denominator, or not the denominator, the second row, this increases by 80, this increases by 80, that increases by 80. So yeah, this is linear, right? That is a constant increase in the number of rats, unfortunately. And at time 0, we can see that there's 1,000 rats. So what's the equation going to be? Well, it's increasing by 80, and it started with 1,000. Right? So we don't even have to calculate anything. We can just look at the table and be able to write the equation out. All right, so those are some examples using linear equations. Again, hopefully these look familiar. Let me know if you have any questions, and good luck on your assignment.